Hi, good morning everyone, and welcome to the second pre-recorded tutorial. I'm gonna be doing this question based on the request that some of the students make, that they are failing to understand some of the concept that is being happening under this scenario. So what I'm gonna do is that I'm gonna do mostly number two. Number one, I'm just gonna explain it, which the solution is already there on the screen. So I'm just going to explain what's actually happening, and then we perform number two where we're calculating the present values. So let's start with the reading the scenario and then analyzing the scenario, and then from there we can solve the questions that we are required to actually get to calculate. So this is the time value of money question. So it goes as follows. It says that Mr. Hopeful has just won 3,500,000 in the lotto and has decided to invest the money. So he won lotto and decided to invest the money. At the beginning of the third year, he wants to purchase a new BMW 318i for 220 and buy his 3 miles for 2 million. So he would also like to withdraw 10,000 per month at the end of each month for the first 5 years, and then 15,000 per month for the next 5 years from year 6 to year 10. The bank has quoted Mr. Hopeful the following interest rate. Year 1 to 5, he's going to be earning an effective interest rate of 10%. It doesn't matter if the nominal is quoted monthly, quarterly, or yearly, or on a monthly basis. It will all end up being equivalent. It must all end up being equivalent to an effective interest rate of 10%. And then from year 6 to year 10 is going to be earning 9% compounded quarterly. So this is all regarding the information. So under this information, if I was to summarize it, I will summarize it in the following method, or in the following way. So he won 3.5 million. That's the amount that he received from Lotto. And he has decided to invest the money. So he's deciding to invest all the money. So at the beginning of the third year, he wants to actually purchase two things, a car and a house, which both of them combined are worth 2,220,000. And then again on the same years, 1 to 5, but not from 1 to 2, but 1 to 5. He wants to actually withdraw 10,000 per month from his investment. And then again, from year 6 to 10, he wants to increase his investment from 10,000 to 15,000 and withdraw 15,000 from year 6 to year 10, and that will be it. So whatever amount will be left, it's for his to enjoy even now or at a later stage. So required number one says calculate the nominal annual interest compounded monthly for the years 1 to 5 and years 6 to 10. So based on the scenario, they told us from year 1 to 5, the bank is quoting him 10% effective interest rate. So meaning that whatever he gets to earn, if his investment is on a monthly basis, whatever nominal interest rate he'll be earning, it have to be equivalent to 10% effective interest rate. So equivalent means that it have to have the same weight at the end of the year as 10%. So based on the calculation here that we did, is to say effective interest rate is 10% on our calculator, and then we go and say payment over the year, or the payment period, is now 12. So what will be the nominal interest rate equivalent to 10% effective interest rate? So we will find out it is 9.57%. So meaning that he actually got to earn 9.57% on a monthly basis until the end of the year, which will be equivalent to actually getting to earn how much? 10% over just 1 year. And then again, it says that from year 6 to 10, it's going to be earning 9% compounded quarterly. So if it's going to be earning 9% compounded quarterly, so this is equivalent to an effective rate of 9.31. So I'm just going to perform this on a calculator so that you can see how we get to this. So we're going to say 9% is our I, and then we're going to say 4 is the frequency of compounding, which is our payment over the year for the first part. And then we're going to go and say second function, effective interest rate. So meaning that from 9%, is actually going to earn over the whole year an effective interest rate of 9.308, which is same as rounding off to the nearest to 9.31%. So from this 9.31%, we can actually get an equivalent rate, which it will be compounded monthly. That would be also equivalent to 9% compounded quarterly, which both at the end of the year, depending on both these interests, they need to actually add up to an effective interest rate of 9.31. So 9.31 becomes our effective interest rate. So it's 9.31 second function present value. It's entered as 9.31. And then we go and say 12, it's our frequency of compounding this time. So second function nominal, so it's equivalent to 8.93 compounded on a monthly basis. So meaning that for someone who's currently earning 9% compounded quarterly, that person is this will earn the same interest as someone who's actually earning 8.93% compounded monthly, because both of them at the end of the year, they are going to have accumulated an effective interest rate of 9.31. So that is the explanation behind the first question. Now moving to the second question, it says that calculate the present value of the amount available from lotto winnings after Mr. Hopeful made all of the above purchases. Assume annual compounded monthly rate of 9.57 for year 1 to year 5, which is equivalent to the one that we calculated on number 1. And then 8.93 for year 6 to 10, which is again equivalent to the one we calculated on number 1. So when we calculate the present value of all the amount that he actually purchased, that we will be left with. So present value, it's all the amount that he actually invested, subtracted on the amount that he actually have today. He actually have 3.5 million today. So this is actually his present value today. But again, the same day today, he's deciding to invest that money. So once he invests that money, he will be left with something, because what he wants to invest for, it's for him to be able to buy a BMW and a house at the beginning of 3 years time, at the beginning of the third year, for 2,220,000 combined together. And then again he wants to be able to withdraw 10,000 at the end of each month for 1 year to the 5th. And then again from the 6th to the 10th he wants to be able to withdraw 15,000. So now on the first period of 1 to 5, year 1 to 5, there are two different types of uh, investment or transaction that are occurring. The first transaction that is occurring between 1 and 5 years is that in 2 years time you will need 2,220,000, which is 220 for BMW and 2 million for the house. So this is within 2 years. So therefore we're going to have an investment for that for 2 years, which is for the car and the house. That will be the time frame for the first investment. And then the second part will actually be what is another investment within 1 to 5 years, is the one where he gets to withdraw 10,000. So these two transactions are occurring at the period of year 1 to year 5, but we cannot calculate them together, combine and say that we have a future value of 2,200,000 and a withdrawal of 10,000. That will be incorrect, because if we're saying the future value is 2,200,000, we're saying that this is for the end of 5 years, but we forgot that this amount is going to be spent at the beginning of the third year, which is at the end of the second year. So meaning that this investment at the end of the second year will be used and then to buy the two assets, and then The other investment will be used to continue with the withdrawal. But for us to be able to calculate the accurate amount that should be invested for him to be able to have 220,000 and 2 million is as follows. So from the car and house, we know that he needs 2 million 220,000 as the amount that he will need to actually buy his house and the car at the end of 2 years. And then we also know that if this was a lump sum for 2 years, he's not going to be making a withdrawal for this investment for the car and the house or additional payment and deposit. So the PMT automatically becomes zero for this one. So we're going to treat this as a lump sum investment, because this is the one where he does not get to withdraw or contribute anything towards this on a period of 1 to 2 years. He's just only going to invest, and then at the end of 2 years, which is going to be the beginning of the third year, that side, therefore that amount is the amount that is going to use, which is the 2,220,000 to buy the what? The house and the car, and therefore no PMT will be there. And then we move to the number N. Number N can be calculated in two methods right now. We have got an effective interest rate of 10%. We know that if he was going to invest a certain amount and earn 2,220,000 at the end of 2 years, this amount is going to earn an effective interest rate of 10%. So meaning that the I could actually be 10%, or since his account is going to be set under the frequency of compounding of monthly basis, so also his interest will be set to 9.57. So this could be 9.57. So this could be another interest that you could actually calculate to get the present value. So here all the amounts will be the same, but you can calculate this based on the two interest rate. But if we're calculating it based on 10%, we're not gonna use the frequency of compounding of monthly, because 10% is for the whole year. So if it's for the whole year, therefore, how many years are there for this investment? It's only 2 years. So N will be, the number of periods of this investment will be 2. And therefore, we can actually calculate the present value. Therefore, for the payment over the year, we're going to set it to 1. Why are we setting it to 1? Because we are using the effective interest rate, which is an annual equivalent rate for his investment, to say that from year 1 to 5, his total investment should only earn 10% over the year. That's what the bank quoted for him, which we also calculated based on the assumption. Here it says assume. So if you're assuming 9.57 and you calculate this, the effective interest rate of this will still be 10%. So we can actually get to use 10% and say that this is what is going to be earning. So this scenario that I'm applying here, or this principle or method that I'm applying, only applies where there are no withdrawals or deposit in within. Because if there are those in within, the balance get to change on a monthly basis. So therefore, a new what we call interest rate will be calculated based on those withdrawal. But under this one, for the investment of the car in the house, the amount will just be invested and then withdraw for these two things. So what actually happened is that now we can actually get to use this information, or put it like this on our financial calculator, to say that payment period, if it's over 1 year, is going to earn 10%, which is the interest rate over the whole year. So meaning that this 10% is for the whole year, so meaning that we can say that's one payment period. And therefore our N, number of payment period, will be frequency of compounding, or multiplied by the number of years, which is going to give us 2. 1 times 2 giving us 2. And then we know our future value, which is the positive amount that you need to receive at the end of 2 years, which is going to use to buy the house at the beginning of year 3. So therefore this is still an inflow to him at the end of 2 years, not an outflow. So the outflow will be the investment that he made today, which will be the present value of the amount that he have to invest for him to actually have 2,220,000 at the end of 2 years. So therefore we're gonna go to our calculator, reset everything. Once we reset everything, we're gonna go and say, okay, frequency of compounding is 1 because we're using an effective interest rate. And then from there, we're gonna go and say, since we've already said 1 payment per year, our N is 2, our I is 10, and then we've got 0 PMT. Then the future value is 2,220,000. That's our future value. So therefore, what will be our present value? So our present value will be 1,834,700 1,834,710,74 cents. So this is the amount that he will need to invest today, so that by the end of 2 years he have 2,220 for his house and the car that he wants to purchase. So I'm gonna come here under the present value and say that the amount that he needs is 1,834,710, 74 cents. So this is the amount that he needs to invest today. So it's gonna be a negative, which is going to be an outflow of cash. So the second method, I explained that you can use 9.57. So his account is actually set up on a frequency of compounding of a monthly basis from year 1 to 5 of 9.57. So if you are going to use this method, meaning that you're going to say that 12 payments of frequency of compounding are going to be made, meaning that his interest are going to be calculated on a monthly basis, which is 12 in a period of a year. So those are 12 payment period over the year. So therefore his number of periods will actually be 2 multiplied by 2 years multiplied by 12, giving us 24. And then here we're still gonna have the same effect where the PMT will be 0 and the future amount that is actually needing will be 2,220,000. Then from there we can actually calculate the present value based on the basic principle to say that this is how much the bank have quoted in, 9.57% over the 5-year period, meaning that any investment will actually earn 9.57, but at the end of the year that investment will actually earn 10% effective interest rate. So when we calculate this is what's going to happen. So we're going to set our calculator to 12 payments period, and then it's going to tell us that interest are going to be calculated over 12 payment period once we clear the calculator, the time value of money calculations. There it is, it shows us. Then from there we're going to go and say our N. So our N is 24. Our I is 9.57, which is going to be our I. So automatically the calculator will divide this by 12 because we already set that on our financial calculator, so we don't have to divide the I. And then we move towards to PMT 0. Future value is still going to receive 2,220,000. Then we go and say this is our future value. Then what is our present value? So our present value will be 1,834,667,19 19 cent. So this is actually the amount that is going to receive. So it's equivalent to the same as the one that we calculated over the effective interest rate. The only difference that is there is because our interest rate have been adjusted to 2 decimal, but on this other side these have been rounded off in terms of the effective interest rate. So if we calculate the 9.57%, the ones that we get here based on the effective, that is equivalent to the effective interest rate of 10%, it have got some numbers behind 57 going there. So if we include all those numbers, we're gonna get the same amount as 710. So due to rounding off, your amount will have a slight difference, which is just a small slight difference of somewhere equivalent to 200 rand, 200 if you are working, if the percentage is not big. But if you round this off to the nearest percentage to say 9.5 and say 10%, the amount here can go up to even be the difference of 500, which you will still be within the same range of the price that you'll actually spend at the beginning of at the beginning of the of year zero. So here we have got the one calculated from the interest rate of compounded monthly to be 1,834,673.19 cents. So this is the amount. So you can see the amount are exactly almost the same, just only the slight difference due to rounding off. So this is the amount that he have to invest today to actually get to accumulate 2,220,000 at the end of 2 years. Then from there we're gonna go and say therefore if he's actually going to also be withdrawing 400, sorry, if he's actually going to be withdrawing 10,000 per month, how much should the investment actually be for this to be able to be achieved, the withdrawal of 10,000 per month from year 1 to year 5? So we know that for him to achieve 2,220,000, he need 1,834,000. This is only equivalent to the withdrawal of 2 years of 2,220,000. But what about for within the period again of 1 year to 5, where it's going to be withdrawing 10,000? So how much are 10,000 withdrawal equivalent to today's value in terms of his investment? So under this one, since this is already monthly, we know that our frequency of compounding will be set it to 12, and then you can still set it to 1 based on the other method that I taught you in class. But in terms of the n always gets to be the number of years multiplied by the frequency of compounding. Even your payment have been set to 1, that one does not change. So therefore our n will be therefore 5 years multiplied by 12. So we're gonna go and say 5 multiplied by 12, giving you 60. So therefore we're gonna have 60, and therefore we're gonna go and say what about your I? So your I here it's 9.57, and then do you have any present value that you're making? That's what we're looking for. PMT, yes, he's going to be withdrawing 10,000 every month, so that's a minus 10,000. And then what is the future value? So there won't be any future value for this, because at the end of 5 years he's going to change this investment and actually earn 15,000. So for the investment of 10,000, it's only for 1 to 5 years, meaning that there won't be any future value for this investment. And then we're gonna therefore be able to calculate our present value. So if you change this to 1, and your n will still remain 60, make sure that you divide the 9.57% by 12 to accommodate your payment period that has been set to 1 on your financial calculator. So therefore we move to our present value. So based on that, we're gonna go and say 12, it's our frequency of compounding. We clear our calculator. Okay, 12 payment have been set, and then we can capture our detail, because now every calculation has been cleared for time value of money. 60 is our number of periods. 9.57 is our interest rate. 10,000 is what we are going to be withdrawing for the first at the end of each and every month for 5 years. So this is actually an ordinary annuity. So if it was an annuity due, we're gonna set our calculator to beginning mode. So we leave it under the end mode. So it might show that it does not have that BEG return here. So this is gonna be an outflow. So that's a PMT, then 0 future value. So this is the function that I'm referring to, BEG. So it's for beginning. Make sure that it's out, because this is an ordinary annuity payment that being made at the end. So therefore we can calculate our present value to be 475,373.60 cents. So that's 475,373.60 cents. So this is also the amount that he needs to deposit today as an outflow to his investment account for him to be actually starting to withdraw 10,000 at the end of the month until fifth year, where there won't be anything to withdraw for 10,000, and then from sixth year it's gonna start again withdrawing 15,000, which is a different story. So this is for the 10,000 withdrawal. So for him to actually be able to earn 10,000 or withdraw 10,000 on a monthly basis from year 1 to 5, he needs to have an investment currently now of 475, 373 included on top of this investment of 1,834,710 to be able to achieve also a withdrawal of 10,000. So this is equivalent to this 220,000 after 2 years, and this 475 is equivalent to all the 10,000 is going to withdraw for the period of 1 year to 5 years. So therefore he needs to invest 475, which is going to be earning 9.57 to allow him to withdraw 10,000 and the account doesn't get to be depleted. And then we can move forward to the last part, which it also becomes a bit tricky as well for those who will miss the time frame. So the time frame for the 15,000, it says that 15,000 per month for the next 5 years, which is year 6 to 10. So meaning that at the period of year 6, he's no longer gonna be withdrawing 10,000. He's gonna move to 15,000. So meaning that he will need an investment that will actually allow him to actually earn 15,000 from period 6 to from year 6 to year 10. So therefore he can actually withdraw 15,000. So under this one, the frequency of compounding is still on a monthly basis. So you're gonna go and say it's 12, and then you're gonna look for your I. Our I, we've been told that it's 8.93. Okay, 8.93, which is equivalent to 9.31 over the year, meaning that over the year for under this investment, you would have actually earned 9.31%. And then we're gonna move towards the interest rate. So sorry, this was the interest rate. So we're gonna move towards looking at our number period. So in terms of the number period, we're gonna say that the investment or the withdrawals that are going to be made are going to be made under investment, which is going to be from year 6 to year 5. So that is equivalent to 5 years. So if it's equivalent to 5 years, so therefore that's 5 multiplied by the frequency of compounding of 12, that's giving us 60 as well. So it's giving us 60. So and then we move from the present value, that's what we are looking for. PMT, we know that from this period he needs to withdraw 15,000, which is going to be a negative amount because it's an outflow of cash. There we have our 15,000 as an outflow. And then what will be the future value for this investment? At the end of 6 to 10 years, there won't be any amount left because there's no other withdrawal that is going to be made or any wish that he have to say that I need to be left with 10,000 at the end of 10 years or 100,000. So there is no kind of that wish. So therefore, we're going to have a zero future value. And therefore we can calculate the present value at a period of 6 years to say that how much should he be having in his investment account at the beginning of year 6 so that he can be able to withdraw 6,000 while earning interest of so that he can be able to withdraw 15,000 while earning interest of 9.3% for the next coming 5 years until year 10 have ended. So therefore we're gonna go to our calculator. It's still under 12 payment period, so I'm just gonna only clear the calculation and I'm gonna confirm that the 12 payment have been set per year. So there we're gonna go and say 60 is our N, and then 8.93 is our I. So this is our interest, so we don't divide it by 12 because we already set the calculator to that. You only divide if you set your calculator to one payment period, and that's when you divide your I. But your N, it's always multiplied by the number of frequency of compounding. It doesn't matter if your calculator is set to 1. Then we move present value is the value we're looking for. So we move to 15,000, which is going to be making withdrawal of, so that's an outflow of cash. Then we say this is the PMT. So at the end of 10 years, there's no wishes that he wants to have some amount remaining. So therefore, we are going to have a zero future value. So how much is the present value at the beginning of year 6 that will allow him to withdraw 15,000? So the present value will be 723, 723. Okay, sorry about this. I made a mistake here of the 10,000 withdrawal. It's an positive cash flow on all of these. So it's a positive cash flow because he is receiving this money. So I'm treating this as a bank. So that's why I'm having it as a negative. So please note that this is a positive. He is receiving this money. So the only thing that will be negative will be the investment he make. So sorry about the mistake that I just explained to say that this is the what we call an outflow. So the 10,000, it's only an outflow for the bank, but it's an inflow to Mr. Hopeful because he's the one withdrawing. So meaning that also here we can go and say 15,000, it's an inflow, and then calculate the present value. So the present value will actually be a negative one, 723,000, 723,000, 784, comma, uh, okay, I missed the percentage, cents, which is 58 cents, comma, 58 cents. So meaning that from the period of 6 to 10 years, Mr. Hopeful will actually receive 15,000, which is an inflow. On the bank side, it's going to be an outflow, so it's going to be negative. But for him to actually get to receive the 15,000 from period 6 to 10 years, his investment account should actually be having 723,784.58 cents. So this is the amount he needs to be having at the beginning of year 6. So the question becomes, so how much is the money that he should be having today under year 0 so that he can invest it for the period of 1 to 5 years, and from the period of 1 to 5 years that amount will be equaling to 723 so that he can earn 15,000 on a monthly basis, because we cannot say this is the amount that is going to deposit today at year 0, whereas we have got 5 years in between before year 6 and 10. So how much is the equivalent of 723 at the beginning of year 6? So we are looking for the equivalent amount of this today at year 0, which is before year 1 to 5. So we know that at the end of year 5, he needs to have a positive inflow of 723,784, which is still going to be a continuation of an investment. So you can actually get to put this as a negative or as a positive. It's still okay. But what we're going to do is that we're going to put it as a positive to say that from today is going to invest 700, from today whatever is going to invest from period of 1 to 5 is going to get 723,784.58 which is what is going to also be reinvested for the period of 6 to 10 years. So when it gets to be reinvested for the period of 6 to 10 years, it's going to earn 8.93. But we know that from the period of 1 to 5 years, any investment made there will actually get to only earn 9.57, or actually equivalent to 10% interest rate, which is annually. For this investment here of 723, which is going to end at the end of 5 year, which is going to be the balance at the beginning of 6 year. From year 1 to 5, for this investment, there are no withdrawals that will be made. So we're going to have a 0 PMT. So meaning that we're going to have a 0 PMT. So me, I'm going to apply two scenarios to say that interest are being compounded on a quarterly basis. Sorry, on a monthly basis. So payment period is either 12, or we can set it to 1. Why are we setting it to 1? For this investment of year 6, which is going to be made at the beginning today from year 1 to 5, and then from year 5 it's going to be transferred to year 6 to year 10. It's not going to be making any withdrawal deposit, so meaning that this investment will actually be earning a 9.57 or an equivalent of 10% effective interest rate. So therefore we're gonna look towards our n. Our n will be still be 60 on both, because that's the period of 5 years, and the frequency of compounding it on a monthly basis. So therefore that's 12 multiplied by 5, giving us 60. So we're gonna still do the same, but this side we can change this and say, since we are saying that you could actually earn 10% effective interest rate annually. Therefore, the n will actually be 5, which is 5 multiplied by 1, which is 5 years multiplied by 1, which is the frequency of compounding, because it's now earning the effective interest rate. So we can use both the two. So you're still going to get to the same amount. Remember, I said this method only applies where there are no withdrawals or deposit in between the year. So that's when you get to apply this scenario to say that, okay, it's gonna be earning 9.57% on its interest on top of the interest, which will actually be equivalent to how much? 7 million, sorry, 723,000, which is gonna earn him 723,784. But this 9.57, which is gonna be earning on top on a monthly basis and on top of the interest that you already earn, will be equivalent to 10% annually. So meaning that he could earn actually, we'll just say that is earning 10% annually, which is the same as what we did for the 2 years one. And then here meaning that the 10% will be equivalent to what is going to earn annually for 5 years. And then 9.57 is going to be equivalent to what is going to earn for 60 months, which is for during the period of 5 years. And therefore no PMT, no withdrawal. This is the future amount that you will receive. So therefore, what is the present value for this investment? So therefore we can go and say that, let's start with the one where the present value is set, the payment or frequency of compounding is set to 12. So it's already there on our calculator. So we're just gonna go and say 60, it's our n, and then we're going to say what is our interest rate. So we are saying that it's being compounded monthly, so therefore our frequency of compounding monthly will be 9.57. And then we move towards to our PMT, which is going to be 0 under the period of 1 to 5 years for this investment. And because it's only going to start withdrawing 15,000 at the end of 6 years. So therefore we're going to have 0 that, and also the future value will be 723,000 784.58 cent. So this is the future value that he needs to receive or to have at the end of 5 years to be able to allow him to withdraw 6,000 starting from the end of each month of year 6 going forward. So therefore the present value for this will be 449,392.15 cent. So this is the amount that he needs to invest today, as in today, so that by the end of the 5th year he will be having how much? 723,784.58 cent. And then this amount will continue this time to earn a different rate from 9.57 to 8.93. And once it's earning 8.93, you can still be able now to withdraw how much? 15,000 at the end of each month, which is going to be a positive inflow of cash. And therefore, this calculation again for this can be calculated in a different method to say that since it's not going to be making any withdrawal, we can calculate this on an annual basis because that we know that the effective interest rate that is going to earn is 10%. So let's calculate that. So meaning that we can go and say 1 second function PMT, and therefore our payments periods have been set to 1 over here. It's going to be earning 10% over each year, and then the number of period is actually 5 years or 5 payment period, which is annually, and therefore the amount that he needs to have by the end of this 5 year is 723,784.58 cent. So that's our future value. No withdrawal deposit will be made, so therefore the present value will be 449,000 449,413.28 cent. So these are the two equivalent amounts that this person could actually earn. So depending on which calculation method you actually performed, you will still see that you're gonna get almost the same amount, but the difference will be slightly because the other one we use the effective interest rate, the other one we use the monthly rate, which have been rounded off to the nearest 2%. So I just want to quickly perform something just to show you guys the difference that will be there. So if we go and say 10% is the effective rate, and we say 12 is the frequency of compounding of monthly, so the nominal rate will actually be 9.569. So if in case of writing 9.57 rounding off to the nearest two decimal, we enter it as 9.569. We're gonna get the exact amount as 449,413.28 cents. So let's do that and see if this is true. So we're gonna go and say 9.569. It's gonna go and say 9.569, which is going to be actually be our interest, not converted or rounded to the nearest two decimal. So this is equivalent to actually 10% that is going to earn over the first 5 years. So therefore that's going to be our I. 12, it's our payment period. 60, it's our N. No withdrawals. We know that he needs 723,784.58 cents at the end of the 5th year. So what will be the present value? So if we check this present value exactly, you will see that we're gonna come back to exactly 413 cents. So 413 rands, so which is the same. So the rounding off that we actually get to use here is the one that gets to give us two different amount, which the slight different will be actually less because we're only taking a look in terms of the decimal behind the number. But if we're rounding off based on to the nearest percentage, therefore difference will actually move from hundreds to thousands this time. Then the more we round off to the nearest 10 percentage, therefore we're gonna have a huge difference now of all the total amounts will actually be different. So therefore this is the cause of the difference in the rounding off. So if you don't round off and you use if you round off to 9.57, you get 449,392.15 cent, and if you use the effective interest rate you get 449. So we are not yet done with the question. So the question says calculate the present value of the amount available from lotto winnings after Mr. Hopeful made all the purchases. So we know that Mr. Hopeful we're gonna have his lotto winnings. So his lotto winning is actually 3,500,000. So we know that his first purchase is in 2 years, car and house. So I'm just going to say car and age for the house. So for car and house, he actually needs to invest 1,834,000 today. So actually he need to invest the following amount for the car and house today from his lotto winnings. And again, for him to be able to withdraw 10,000 from year 1 to year 5, he needs uh, hmm, so what can actually happen here is that instead of saying that for 1 to 5 years you should only invest 475 for 10,000, you can combine the two investments, these two. This one for the 1 year to 5 of 15,000 and the one for 10 years, because these two investments will be made simultaneously together at the same time. So this will be equals to the investment for 10 years plus the investment for 15,000. So meaning that in total, in terms of year 1 to year 5 again, he needs to invest 924,765.75 cents between year 1 to year 5, which this investment, which is going to make between year 1 to year 5, it's going to allow him to withdraw 10,000. And once it allows him to withdraw 10,000, by the end of the 5th year, you will actually get to have a remaining balance of 723,784.58 cents. You can confirm this through a calculator by just going and saying, let's see if this is actually true. So our payment has still been set to 12. We are saying that from the period of 1 to 5 years, is going to earn 9.57%. So this will be the amount that he earn. So 9.57%. And therefore it's going to be the interest that is going to earn. So the period is 60, the number of period, and therefore the PMT that is going to withdraw it's 10,000. So it's going to be making a withdrawal of 10,000, which is a positive amount, so it's an inflow to him. And the amount that he have to invest today is 9,765,75 cents. So this is the amount that he needs to invest today as a present value. So what will be the future value? So the future value will be 723,787.58 cents, which is the one that we get here at the beginning, at the end of 5 years. So this amount that will be left will now change from earning 9.57% to 8.93%, which is going to allow him then from year 6 to actually continue to withdraw now an increase of 15,000 from 10,000. So therefore the present value of the amount that Mr. Hof will have, so the present value will be equals to the lot amount he received minus all these amounts that he have here. So since some of them are already in the negative, so I'm just gonna do this to say that 3 million minus the investment for car and house and the investment for his lump sums. So therefore this is equal to 740,523.51 cents. So this is the amount that he actually gets to have by the after making all the purchases. So he's going to make a purchase of an investment for 2 years of 1,834,710.74 cents for his car and house investment, and then he's still going to spend 924,765.75 cents, which will allow him to withdraw 10,000 from year 1 to 5 and then 15,000 from year 6 to uh, 10. So this is the present value of all his investment. After making all his investment, his present value is 740, meaning that he can spend 740,000 anyhow he likes, because he would have achieved his dream over the next coming 1 to 10 years based on his investment. So this is all in terms of these questions. So if you still struggle, just send me an email on which part you actually need assistance on. So that will be all for today's lesson. Please enjoy the rest of your days and practice and make sure that you pass your assessment and exams.